Thank you. Well, I told you what X-Informatics was in the panel, so I showed a version of this slide in the panel, and it's I repeat it because I think it's a helpful way of understanding what we're trying to do and why these various topics such as clouds and data analytics and big data are important. They are ultimately important because of the various applications. And the applications can be called X-Informatics, such as Bioinformatics, or they can be called e-biology or e-science. So if you look at what's going on, at least in industry, there's an enormous growth in this area. I don't think it's so true in scientific research I don't think big data's had quite so much impact as it has had in the industry. And I would typically say that industry is ahead of academia in both the use of clouds and the use of big data. And the other term which we will use is data science, which somewhat ill-defined again, but data science is the academic field which has something to do with training people in this basic area. And here's this again, the same slide, and this is just cut and paste from the web, and you will find that there are many areas of informatics defined, and many, if not all of them, have large amounts of data associated with them. So these are the topics this presentation will discuss. We will start off with the, which I call the economic imperative, that there is a lot of data and a lot of jobs. Some remarks about the computing model, where industry has adopted clouds, and probably academia has not adopted, at least in the US, academia has not adopted clouds. Some comments on the research model, the so-called fourth paradigm, data-driven science. Some comments on data science education. What I call the confusion in this new-old field. It's big data is somewhat a new field, but people have been